All right, this is Algebra 1, Lesson 2 of our Unit 3. This is on page 8. We are just doing number 5. We are doing function notation from a graph. All right, so we've done 3 different types of function notation. We've done it from the equations. We've done it from a table, and now we're interpreting it from a graph. This is potentially one of the more confusing. You just have to know to match up the x values and match up the y values. And this is where the practice comes in, because it will really help you just to practice and get that muscle memory of what you're looking for when we're dealing with especially the x-axis and the y-axis. All right, so we have 4, we're using our function notation here, we have 4 input values. And like before, if we have an input value, we just want to figure out what our output value is, or our y value. So I got 4 different x values, and I just want to see what its corresponding y value is on the graph. So if I go to -2 on the x-axis, remember my x-axis is my horizontal one. Well, let's look at number 2 right here, or -2, -1, -2. -2 is right here. Now, looking up or down, what I need to do is find the corresponding y value. Where is there a point when the x is -2? Well, the only point I see is right here. Now, what y value is that? It's at -1, -2, -3. So what this means, it literally is a coordinate point. When my x value is -2, my y value is -3. Okay, so same thing here. Let's do some more practice. My x value is 3, so I go on 3 on the x-axis, 1, 2, 3. If I look up or down, where's my corresponding y coordinate? 1, 2, 3, up, 4. When my x value is 3, my y value is 4. Not too bad. G of 0, all right, so x is 0. My input 0. Where's my corresponding y value? -1, -2, up, -3. That's okay if we have 2 -3s for my y values. Remember, the definition of a function is 1 y value for every x value. You can have y values that repeat. That is okay. You just can never have x values that repeat. And obviously this is a function because it passes the vertical line test. We can draw a vertical line throughout, and if it only touches once, we have a fraction. All right, here we go. G of 7. So my input is 7. My x value is 7. 1, 2, 3, 4, 5, 6, 7. Now, this is the tricky part. And I don't want to oversimplify it, but if my x value is 7, if I look up or down, there's no other point except on the x-axis. And whenever any point is on the x-axis, my y value is always 0. That's how you do that. Okay, here we go. For what values of x does g of x have at 0? So what this means is, and this is where potential some confusion may set in, my y value is 0. So I need to look and see on this graph where all my y values are 0, which is basically the x-axis. My y value is 0 here, 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 and here. There's 4 points. 1, 2, 3, 4. And all I got to do is put those x values. So if the y value is 0 here, my x value is -1, -2, -3. My y value is 0 here, which is an x value of 1. My y value is 0 here, which is an x value of 5. And then finally, my y value is 0 here, which is an x value of 7, which is kind of what I got up there. All right, here we go. Last one. For what value of x does the function have the output at -4? So I look down and see where my y value is -4. -1, -2, -3, -4. And this is where I look to the left or the right. How many points do I have when my y value is -4? Just 1. And what's that x value? So now I look up. 1, 2, 3, 4, okay. Up, that's at -1. What that means is when my x value is -1, my y value is -4. See, you can have repeating y values, that's okay. Just no repeating x values. All right, that was number 5.